Chapter 5.3 is the normal distribution and finding values. So we're still going to be needing that z-table for this section. So before, what we were doing, we were using z-scores. So either we were given z-scores or we found z-scores, and we were using that to find the area less than a value, greater than a value, or between two values. Now we're going to be going in the reverse direction, and we're going to be given the area or the probability to find the z-score. So a similar concept, but the exact opposite direction. So what we're going to be doing is finding the area in the table and then finding the z-score that corresponds to that area. So one issue that we'll get with this is that the exact value, the exact area value, will not be exactly in the table. If it's not in the table, we have to either use the z-score closest to that value, or if the area is exactly halfway between two values, we're going to use the mean of those two z-scores. So we'll see those two in an example when we get there. So let's do some examples. Let's find the z-score that corresponds to a cumulative area of 0.3632. So a cumulative area of 0.3632, that means area to the left. So we're going to find the z-score, let's say it's about right here, such that the area to the left of it, which is this area right here, corresponds to an area of 0.3632. So what we have to do is look for this value in the table. So what we're going to do, we're going to go to the z-table. So it's right here. So we're looking for an area of 0.362 inside of all of these areas. So it helps to understand how this is set up. Since the table on the left over here is the negative z-scores, that's going to be areas between 0 and 0.5. So we know our area is going to be somewhere over here on this one on the left. So zooming in here, we're looking for 0.3632. So it starts at close to 0 up here. Further we go down to the right, it gets larger. So we should be expecting it somewhere down here. So it actually is down here. It's right here, 0.3632. I'm going to circle it so it's easier to see. So the z-score that corresponds to that is going to be negative 0.35. So that is going to be our answer for that one. It's z equals negative 0.35. So that is the z-score that corresponds to that area. Okay, let's do another one. Find the z-score that has 10.5% of the area to its right. So this is as a percent. So we have to change this to a decimal. We have to move the decimal point over 2 to the left, so we get 0.1075. So this is area to the right. The table tells us the area to the left. So what we have to do is 1 minus 0.1075, which is 0.8925. So that's the value we're going to look for on the table. So originally we're trying to find the z-score where 0.1075 was on the right. So maybe that's about right here. So maybe this area right here represents 10%. So that means this would be 0.8925 to the left. So looking for 0.8925 on the table. Since that number is a little bit larger, it's going to be over here. It's greater than 0.5, so it has to be on the right side of the table. And that's going to be about right here. 0.8925 corresponds to a z-score of 1.24. So that means z equals 1.24, has an area of 0.1075 to the right. So it's good to double check go back over to where you kind of eyeballed where it would be to see where it makes sense based on the percentages of the areas to the left and to the right, and it looks like that's about correct. Okay, next one, find the z-score for which 95% of the area lies between negative z and positive z. So this one's going to be a little bit harder here. So we're trying to find 95% of the area between negative number and the same positive number. So let's say it's about right here. Oops. Right here and right here. So just eyeballing it. And say about 95% of the area is between this. So this is 0.95. So we need to somehow relate this so it's an area to the left, because the table tells us only areas to the left. So we have to find, one way to do it is find this value right here, the area value right here. So to do that, we have to understand that there's 5% on the left and 5% on the right. Or sorry, the 5% outside total. Since there was 95% between those two values, there has to be 5% outside, which means there has to be 2.5% here on the left, and there has to be 2.5% here because it's symmetric. So as a decimal, that means the area over here has to be 0.025, and over here also 0.025. Okay, so there was 95% of the area between them, which means there has to be 5% outside of them, which means 2.5% on the left, 2.5 on the right. So the value we're going to be looking for is this value in here. That's going to be our negative z, and then the positive version of it is going to be our positive z. So we're looking for this in the table, and we're going to see what z-score that corresponds to. So z-table, we're looking for 0.025. So 0.025 is going to be over here because it is smaller than 0.5. So 0.025 is right here. That corresponds to a z-score of negative 1.96. So that was our negative z. So negative z equals negative 1.96. So positive z is just going to be the positive version of that. So that means that 95% of the area under the curve lies between a z-score of negative 1.96 and positive 1.96. Okay, a little bit more confusing for that one. So it helps to have the curve drawn. So let's find the cumulative area, or find the z-score, sorry, that corresponds to a cumulative area of 0.9. So once again, cumulative means area to the left. So that's going to be 90% of the area to the left, so maybe about right here represents 90% of the area under that curve. So we're trying to find that z-score that corresponds to that area. So since that's area to the left, we can just look that up in the table because that's what the table tells us. So looking for 0.9, we end up getting about in this area right here. We have 0.8997 and then 0.9015. So 0.9 is not the midpoint between them exactly. So we pick the one closest. The one closest to 0.9 is 0.8997, and that corresponds to a z-score of 1.28. Okay, so that was an example where we had to pick the z-score closest. So I'll say 0.9 is approximately 0.997. So that means z-score was 1.28. Okay, next one we have find the z-score that 5% of the area is to its right. So 5% means we need it as a decimal, so it would have to be 0.05. So 0.05 or 5% to the right, that might be somewhere over here, where this area in here represents 5%, 0.05. So since that's an area to the right, in order to use a table, we need to use an area to the left. So finding the area to the left, we're going to do 1 minus 0.05, which is 0.95. So that is going to be the area to the left. So that's going to be the value we look for in the table. Okay, so it was given to us as area to the right. We had to find the area to the left first. So looking for 0.95 in the table, we know it's going to be over here on the right because it's greater than 0.5. So 0.95, we get to right here. So 0.9495 and 0.9505. It is exactly the midpoint between those. It is the average of those exactly, the median. So what we have to do is take the average of their two z-scores. So we have to take the average of 1.64 and 1.65. So I'll make a note that 0.95 is the midpoint between them, or the median. So 0.95 is the median of 0.9495 and 0.9505. So we take the average of their z-scores. The z-score for 0.9495 was 1.64. The z-score for 0.9505 was 1.65. So the z-score for our value of 0.95 is the average of those, which is 1.645. So you have to take the average of those, so you add them up and divide them by 2, and you get 1.645. Okay, so for the next thing, now we're going to be transforming a z-score to an x value, which is a data entry value. So to do this, we're going to be using this formula. It's x equals mu plus z sigma. So the x value equals the mean plus the z-score times the standard deviation. So this is the same thing as the z-score formula. So let's start with that just to get a quick derivation of it. X minus mu over sigma equals z. So just a little bit of algebra. We would multiply both sides by sigma, which would be cross multiplying. So that's z sigma equals x minus mu. And to solve this for x, we have to add mu to both sides. So we would get z sigma plus mu equals x, which is exactly what that is up there. So you don't have to know how to do that derivation. This is an algebra-based class, but just know that these are the same formula. One solved for z, the other one is solved for x. So before we get into these questions, let's just do a quick little reminder of what we were doing previously in the other sections. So we were given an x value, and then we had to find the z-score for that x value, and then we had to find the area under the curve for that z-score. Now we're going to be given the area underneath the curve, and we're going to have to find that z-score and use that z-score to find the x value. So the complete opposite direction of what we were doing before. So let's start off with an easier example where it's not that whole thing just yet. So let's say we have the weights of cats are recorded and we know that they're normally distributed. We have a mean of 9 pounds and a standard deviation of 2 pounds. So we know that mu equals 9 and sigma equals 2. We want to find the weights. So weights are the data entries, which are x values here, corresponding to the z-scores of 1.96, negative 0.44, and 0. So let's find the x value, the weight, that corresponds to the z-score of 1.96 first. Okay, so what we're going to be doing is using that formula that was written above, x equals mu plus z times sigma. So we have mu, we have sigma, and we have z for this particular question. So we're going to plug these in. We have x equals 9 plus 1.6 times 2. So when you're doing this, make sure you're doing order of operations correctly. You have to do the multiplication first, 1.96 times 2, and then you add 9, and you should get 12.96. So this was a weight, and it was a weight in pounds, so 12.96 pounds. So what this means is that a weight of 12.96 pounds is 1.96 standard deviations above the mean of 9 pounds. Okay, next let's do it for a z-score of negative 0.44. So same formula, x equals mu plus z times sigma. So it's the same thing, we plug everything in, so it's the same mean of 9. Yeah, same mean of 9. So 9 plus our z here is negative 0.44. Sigma is still 2. You do the multiplication first, and then you add the 9, and we get 8.12 pounds. So a weight of 8.12 pounds is 0.44 standard deviations below the mean. And now let's do it for the last one, which was 0. So we should be able to figure this one out without doing any work. It's 0 standard deviations away from the mean. But let's plug it in and see what happens. So x equals 9 plus 0 times 2. So we get x equals 9 plus 0. So x equals 9 pounds. So once again, we should have known that without doing any work. If it's 0 standard deviations away from the mean, that means it is the mean, which was 9 pounds. Okay, so let's do a couple other examples here, but before that, we're going to mention this this first step that we're going to have to do. Now we're going to be finding a data value, which is x, so we're going to be finding the x again, except this time for a given area or probability or percent. So that's what I mentioned a second ago, a few pages ago. We're going to be given an area under the curve, under the normal curve. We're going to use that to find the z-score, and then we're going to use the z-score like we just did to find the x value. So say scores for an admittance exam are normally distributed with a mean of 50 and a standard deviation of 10. A student will only accept students with scores in the top 10%. What is the lowest score a student can earn and still be accepted? Okay, so we know we are looking for x. We're looking for the actual data entry. So we know we're going to be using x equals mu plus z sigma. So anytime that we're looking for a data entry, which it is a data entry, it's the score. We know we're using that formula. So we are given the mean is 50, standard deviation is 10. So just move that over a little bit. So we're given that mu is 50, sigma is 10. So we don't know what z is, right? We still need to find z. So we need to do that using the fact that it only accepts students in the top 10%. So we're looking for the z-score that corresponds to an area of 10 that has 10% of the area to its right. So 10% as a decimal is 0.1. So we're looking for the z-score. Say it's somewhere over here maybe, such that 0.1 of the area is to its right. In order to find that z-score, we have to find the area to the left, which is 1 minus 0.1, which is 0.9. So we can use the table. So the area to the left is 0.9. So we're looking for the area of 0.9 in the table, and we're trying to find the z-score that corresponds to that. So let's find that 0.9. So 0.9, we actually had this value in the beginning. It's closest to 0.8997. So the z-score that we're going to be using is going to be 1.28. Okay, so I'll put a little note, 0.9 is approximately 0.8997, and that's going to give us a z-score of 1.28. So now we can plug all these values into our formula. So it's x equals mu, which is 50 plus 1.28 for z, times 10 for sigma. So 1.28 times 10 is 12.8, plus 50 gives us 62.8. So a score of 62.8 is going to be the cutoff. Everything greater than that, they'll be accepted in. Everything lower than that, they will not be accepted in. So 10% of the students scored higher than a 62.8. Okay, for the next one. In a randomly selected sample of adults, the mean total cholesterol level is 181 milligrams per deciliter, with a standard deviation of 37.6 milligrams per deciliter. So assume the total cholesterol level is normally distributed. If it's not, we wouldn't be able to do this. And then we want to find the highest total cholesterol level an adult can have and still be in the bottom 1%. Okay, so before we do anything with the normal distribution, we're given the mean is 181. We're given the standard deviation is 37.6. We're looking for a data entry. We're looking for the cholesterol level. That means that's an x value. So we're going to be using x equals mu plus z sigma. We have mu, we have sigma. We need to find z using the fact that we're given this 1%. So 1% as a decimal is 0.01. So the bottom 1%, what that means, it's an area to the left. If it's everything less than that z-score is going to be 1%. So we're looking for the z-score, maybe right over here. The area to the left is going to be 0.01. So that's what we are looking for in the table, because it is already an area to the left, so we don't need to adjust it. So we're going to go to the table and look for 0.01. 0.01, it's going to be over here because it's small, it's less than 0.5. So 0.01 looks like it is between those two values. So it is not exactly between them. It's not the median between them. So we pick the one that's closest. The one that's closest is this one, 0.0099. And the z-score that corresponds to that is negative 2.33. So I'll put 0.01 was approximately 0.0099. which gave us a z-score of negative 2.33. So it's saying that anything less than 2.33 standard deviations below the mean will be in the bottom 1%. So there's our z-score, so we can plug everything in. So it's x equals 181 plus negative 2.33 times 37.6. We plug all of this stuff in and we get 93.39, and the units are milligrams per deciliter. So the other question didn't have units. It was an exam score, but it wasn't necessarily as a percentage. It wasn't given to us as a percentage, so it didn't have units. So that's why that one didn't have units. This one does have units. It's a cholesterol level. So that is our answer. So anything less than 93.39 milligrams per deciliter will be considered in the bottom, to be in the bottom 1%. Okay, so that is it for this section.